Hi, George.
Hey, Bob. How are you?
Good. How are you doing?
Long time no see.
It's been a while.
Yeah.
But, you know, somebody's got to fill in for John Horgan when he's failing to exhibit the kind of work ethic that made this nation great.
No, where is he?
Oh, who knows? I don't even want to. I can't speculate on the air. We'll have to talk offline.
Yeah. It's. I guess he's working probably.
That seems to me pretty unlikely in his case, but it's possible.
Well, it's a university job, but apparently he does have to show up at the office.
No, he does have the disadvantage of being mired in the old economy, the bricks and mortar economy, where you have to go to a physical space.
Yeah. It's been a long time. I mean, my office is upstairs, and it's not connected by an internal staircase, so I actually do have to get up and get dressed in the morning and commute by walking upstairs.
Yeah, my best situation ever, in a way, was when we lived in an apartment in Washington when we were first married, and I leased on another floor a studio apartment that I used as an office. That was exactly the right degree of separation.
That'd be perfect. Yeah, and I don't mind. I mean, sometimes in the winter I even have to snovel show. I have to shovel snow to get to my office, which is invigorating, and then the blood's flowing through your brain, and you can sit down and work.
Builds character.
Right.
So, listen, is it true? You know, by the way, I have to apologize. I'm not going to be able to fill John Horgan's shoes. I'm not a natural raconteur.
Oh, I bet we could get you to raconteur a bit, but we'll see what happens.
I'm not from the storytelling tradition. I'm sorry, my family is just not big on telling stories. Yeah. Now, my wife, by far her preferred mode of presenting any form of information is narrative mode, and she and John Horgan are both come from an Irish background. Maybe that explains it.
Well, it could. Yeah, and I have a little. I have kind of the Scotch-Irish.
I've got some of that, but apparently not enough.
Yeah, but then I don't know. Your first book, Three Scientists and Their Gods. You were quite the storyteller.
I kind of adopted writing. If you have time to think about it, I can put together a narrative.
Okay, yeah, like crafting a narrative as opposed to just having one spin off the top of your head.
Right.
Yeah.
They don't come out easily. They don't flow the way they do from John's tongue. So I was thinking instead we might actually talk about science or something.
Oh, well, yeah, why not?
I mean, it's a who knows? Maybe it'll work.
Maybe it'll result in some stories.
And so you have some kind of news flash from the realm of...
about quantum computing. I was thinking back to several years ago when you and I did one of those, I think they called them breakfast tables or something on Slate.
Well, they had both breakfast tables and dialogues. I'm not sure which one this was.
Things. Yeah, there are only two, so maybe it was...
But this was about your book, right, on quantum...
Yeah, it was conveniently timed for about when my book on quantum computing came out, and
it's called A Shortcut Through Time, or what? What's the name of the book?
It's called A Shortcut Through Time.
Right.
And I was just actually looking at the book a little while ago. It came out in 2002, and I was and then I've kind of put the subject on the back burner. But I got an email earlier this month from this guy Christopher Monroe at the University of Maryland and the Joint Quantum Institute in College Park, Maryland, telling me about a breakthrough they had. And Christopher Monroe is one of the real top quantum computing researchers. So he was describing this experiment where they broke a record in entangling two atoms that were 1 meter apart. So it was the largest separation of two atoms that had been entangled, according to, this is what Einstein called spooky action at a distance.
Yes. Now this, we may have to pause and explain to readers who have a different conception of what entanglement means. I mean, this is...
There are entanglements and there are entanglements.
I mean, so we're going to plunge into how bizarre the world of quantum physics is right away, I guess. Then if we're going to explain entanglement, right?
Oh, well, sort of, yeah. I mean, again, it's like one of those things that's a lot easier to do when you can sit down and craft something over hours or days than just spinning it off the top of your head. But
I'll use hand gestures to simulate high-priced graphics, okay? Here's the way I think entanglement works, okay? You've got these two particles, and they're like, say they're photons, okay?
Yeah.
apparently they have some property called spin and let's leave aside what it means, since I don't know anyway what spin actually is.
But
you
it can sort of pretend that it means they're spinning clockwise or counterclockwise.
Okay, let's say that.
It's not exactly right. But
now, there is... okay, so what you do is you send them shooting off in different directions, and you measure one at one point. You intervene in the path of one and measure its spin.
Yeah, right.
Which you don't know until you measure it. It could be either one.
Yeah, it could be spin counterclockwise or spin clockwise, and then you hold up your spinometer and measure it, or have it crash into your spin detector, and then you know if it's one way or the other.
Okay, so you measure the one photon spin, and it is guaranteed by a law of quantum physics that at the moment you measure the spin of that one, the spin of the other one will be, what, it's either the inverse or the same, but it's...
depending on how the experiment's set up.
But it's that will determine what the spin of the other one is. Now, the naive observer might think, well, if you can always predict that they're going to be the same, that must just mean that, like, they started off with this correlation, and that correlation persists throughout. It's kind of like, identical twins separated at birth, right? It's like, yes, you can predict, you stop them at age 18, and there's these two boys, and you check them, and they've both developed hair on their chest. That's the same color.
Right.
Well, that's not mysterious. It was kind of in there. The correlation was set from the beginning.
It was a mechanism that was cranking along the whole time.
All the while. The correlation existed all the while. Yeah. But what quantum physicists assure us is that is not the case with these two photons.
Well, yeah, I mean, the idea is that each photon, when it emerges from the experiment and the two go in the different directions, each one is in a superposition of spinning clockwise and counterclockwise simultaneously. And in fact, in a superposition of all the possible combinations of clockwise and counterclockwise, or up and down, or whatever you're using for your quantum characteristic, and it exists in this, it hovers in this state of superposition until you measure it, and then you collapse the superposition, and it randomly takes on one specific value.
So in other words, if you ask the theoretical question, what is its spin at this moment, and you're not measuring it,
it's the answer question. Yeah.
The answer, the answer is not 1 or -1. You might phrase the answer as, well, its spin is all possible spins or no particular spin. You might put it either way, but it's...
Yeah, or it's a list of probabilities.
But there is no answer until you intervene and measure it. And and here we already get into the philosophical kind of interpretations of quantum physics, but I think the way a lot of people put it, with the act of measurement forces it to assume a definite state.
Right, and since it's entangled with this other particle, so if one's spinning up, the other's spinning down, then you know then that the other one, you know then what the spin of the other particle is, even if it's like on the other side of the universe, and even though no signal has passed between the two photons, because to do so it would have to happen instantaneously, which would be impossible. So,
right. Now, George, do you think at this point anyone is still watching?
Yeah, maybe we shouldn't have started with...
What do you say we call it a day?
Quantum entanglement is just one of those...
Yeah, maybe I forced this off on that tangent.
Yeah, and in the past they've demonstrated quantum entanglement at tiny little distances, but what Monroe's lab did was they did it like practically a yard apart. So, and the reason this is important is because in quantum computers, where you're kind of exploiting the idea of quantum mechanics to do computations that you couldn't really do with a regular computer, that's the way that that some of the quantum parts would communicate with each other, through this quantum entanglement. So the fact that they demonstrated this happening at a fairly macroscopic, at a very macroscopic distance is, it's a pretty big deal.
Yeah, I mean, I'll take your word for it. I had no idea over what kinds of distances they had actually demonstrated entanglement.
Yeah, I have to go back and look. But, it's so interesting. The idea of a quantum computer is and again, it's this thing where in a regular computer, it's made up of all these little switches that can be 1 or 0. And it has to be either or. Well, in a quantum computer, the little switches, which could be these spinning photons we're talking about, the little switches can be in a superposition of both 1 and 0. And it turns out that because of that, you can cram just a vast amount of computation into a tiny, tiny little space.
Right. And now let me lay out the part of this I think I learned from reading your book, A Shortcut Through Time. And to me, this drove home how weird quantum physics is. And I really would encourage people to ponder how weird quantum physics is. I mean, this has been done a lot. People who know the popular science literature know that. I think maybe it was Heinz Pagels who coined the term quantum weirdness. So a lot of people are familiar with this, but it just completely blows my mind how it illustrates how far we are from having any kind of grip of what the actual nature of reality is. I mean, when this first maybe got my attention in a really vivid way was when, do you remember Charles Bennett? He may still be at IBM, a really deep and pioneering researcher into kind of the physics of information processing. And he said to me back when I was doing a lot of science writing, I mean, he said according to quantum physics, two flatly contradictory things can both be true at the same time. That got my attention. And since then, the more I've kind of learned about quantum physics, the more amazed I've been. So anyway, what your book illustrated to me was, as we said, a premise of quantum physics is that, like, say this electron's traveling along, and you ask, well, like, where exactly is it? Or you ask for some information about its, velocity, its location, whatever. According to quantum physics, the answer is, sorry, there is no clear answer. We can show you a kind of a probability curve, telling you what, if you intervene and measure it now, what measurement you'll get, but the fact is that measurement is, in a certain sense, just not true until you
do the measurement.
Right, and there's kind of two ways to think about that. One way to think about it is, well, okay, so as the electron travels from here to the point where it's going to be measured, maybe it just doesn't exist. Okay, you could think of it that way. It's not meaningful to talk of an electron existing. Or alternatively, you could say, well, it kind of exists in all of these different states that are kind of mapped on this probability curve. You can think of it as being in all these places or with all these velocities. You can think of it either way. And when I read your book, I realized, and you may tell me I've got this totally wrong, but the impression I got was the amazing power of quantum computing, and we should say it's only been done on the smallest scales, actual successful quantum computing.
Yeah, well, they found the 2 prime factors of the number 15.
Right, which they say are 3 and 5.
3 and 5,
After a couple of hours of reflection, I concurred in that. But the way they get these kinds of answers way faster than a regular computer is, I think this is kind of true.
Okay.
That in a regular computer, you would take that electron, and you got the one electron, and it can kind of do a little work. But in a certain sense, they take all the different electrons that electron becomes in between stage A and stage B. And they have each of those versions of the electron working simultaneously. In parallel.
Yeah, right. And then they collapse the superposition, they get the answer.
Right, so like normally, I guess the way you could think of it is like an electron. Suppose we compare it to a binary switch, and you think, well, a binary switch can only kind of, do so much information, represent so much information between here.
I think it works better if you think of a whole row of binary switches, and a whole bunch, ones and zeros, and some pattern, say, representing a problem that you want to solve.
Where you're saying that's what the whole array of these kind of pseudo-electrons in this intermediate state represent.
Yeah, so then instead of having an array of these bits that are 1 or 0, which might be switches or transistors, imagine that each one is a particle or an atom that's spinning clockwise or counterclockwise. And one way is called 1 and the other way is called 0. So you can have in superposition then all the possible combinations of each atom being 1 or 0, and have the superposition of all these different bit strings, each one representing a different computation. So you're doing all of these in parallel in this quantum superposition, and then when you collapse it, the answer to the problem falls out. So that's kind of a metaphorical way to think of it.
But it just freaks me out that this electron... I mean, it's one thing to say... It's kind of like this electron exists in all these different places.
Yeah.
It's one thing to say that, but then when you get all these different versions of the electron to be working simultaneously, and that's what massively increases the computational power, then I'm thinking, whoa, I guess I'd better take seriously this claim that this electron, in some sense, becomes all these different versions of itself.
Well, yeah, that's right. I mean, because before, quantum mechanics, we'd read and take on faith from physicists who write these popularizations that this is the way the world works on the subatomic level, that we can use it and solve problems, and we can predict and get answers with just incredible precision. And you think, well, that's really impressive, but maybe this is just still kind of a way in which you're analyzing the data and thinking about it. But that's different, more of, I guess, an epistemological and an ontological thing of saying that it's really like this. But then when you start, building these little, so far just kind of toy quantum computers, but they're actually doing this and manipulating quantum states and getting answers, and then you think, wow, there's something going on there.
It's like physicists, they're often, a lot of them will tend to say, when you say, well, what does this mean? So what's the reality really like? They say, don't even think about that.
Yeah, right.
The math works. It obviously doesn't make sense to the human mind, but the math works.
Yeah.
But with quantum computers, there is clearly implied a picture of what the actual reality is that just really drives it home, is all.
And that's what's really, a lot of the quantum computing people that I interviewed when I wrote the book, what really excites them is just that they have this playground now. It's kind of like when you took physics in college and they had the almost frictionless tracks that they used to demonstrate Newtonian mechanics by, sliding little hockey pucks along them and timing the deceleration. So now it's sort of like they have the equivalent of this kind of frictionless track, except it's little lab toys that they can try out quantum mechanics and play with it. And there's really a lot more excitement there among the people who are actually doing this at the theoretical level than the thought that anytime soon that we're going to be able to buy a quantum computer, and keep it in the closet.
Although if we ever do, they will just be massively more powerful than the computers we have.
Yeah, the problem now is that with the best technology, they'd also be massively huge and have to be cooled to near absolute zero to operate, and would probably require a staff of maybe dozens or people working around the clock. So there's a lot to go on the technology.
That still sounds more reliable than Windows Vista.
Well, yeah.
No, just kidding. Cheap shot.
Yeah. Well, our QuickTime 7.2.
Let's don't go there.
Okay.
Yeah, you had some issues with QuickTime today. The upgrade that turned out that was a misnomer, I guess you would call version. What was that, 7 point?
Well, there's the QuickTime Pro player, which is also the recorder used by the Mac contingent of Blogging Heads TV. They updated from 7.16 to 7.2, and for some reason 7.2 just really didn't work well on my machine, so I went back to 7.16.
Yeah, I often find that with upgrades. I'm wanting to downgrade, but
yeah, and it's weird because I went on the web and looked, and I thought, well, surely a lot of other people are having precisely this problem, but they don't seem to be, and yet this is supposed to be this deterministic machine, my computer here running these algorithms, and yet mine is acting different from other people's. So maybe cosmic rays are more likely to, zap the memory on the second story of my house here at the high altitude of 7,000 feet.
Well, speaking of determinism, that's one of the many other freaky things about quantum physics is, of course, it called into question this whole idea. This is one, who put this to me this way? I think it was John Polkinghorne in one of the Meaning of Life TV interviews.
Yeah.
Who of course, is a theologian, so very much likes the idea that quantum physics would show us that the material world is in some sense, or standard material explanations are inadequate or hint at something larger. But he did make a validly interesting point, it seems to me, which was that he said, quantum physics implies that things happen in this universe for which there is no physical cause, and that's actually an accurate reading of quantum theory, I think. In other words, there are these supposedly random fluctuations at the quantum level, and if you ask yourself, normally with randomness, like flipping a coin, we don't know what the outcome's going to be, but the fact is, if you knew enough about the physical system, you could predict it, because it comes down
deterministic. Yeah, like you could, in theory, you could take the coin and analyze it and see if one side's a little heavier than the other or more susceptible to different kinds of turbulence, and then if you measured exactly where you, the point in which you flipped it, you could compute all the physics. And Percy Diaconis, the mathematician is he at Berkeley or Stanford, somewhere out there, he had this really neat coin flipping machine that he demonstrated at a AAAS meeting once, American Association for the Advancement of Science, and which he could predict with just uncanny accuracy, whether the coin would end up heads or tails.
But with quantum physics, you would not ever be able to do that.
No,
what they say is
it's
that
not randomness. The randomness doesn't come from your ignorance of all the factors. Right.
Einstein believed that it did. He remained a determinist and doubted what is now considered the valid interpretation of quantum physics, and that's what it meant when he said God does not play dice.
Yeah.
In other words, nothing is really undetermined in this universe, but according to quantum physics, it is.
Yeah, it's fundamental. It's not just hidden variables, which is what Einstein was hoping to find.
Right. In the case of the coin flipping machine, when they figure it out and can predict what the coin's going to be, they have discovered the hidden variables. But quantum physicists say, no, there are no hidden variables. So
something called Bell's theorem is taken to have established that it can't be deterministic and there can't be hidden variables unless you want to accept the possibility of instantaneous communication, where you could have something could happen across a distance without any time transpiring, which leads to all kinds of problems then with reverse causality and time travel.
And it leads us back to entanglement too, because
that's right.
And here's where I think entanglement is a little weirder than you think it is. Here's my line, okay? Okay, we go back to these two photons. They're heading out, and you measure one, which force it to assume a spin, or there's this variable that it assumes a fixed version of, forces it to assume a spin of say -1.
Right.
Which it did not possess until you measured it, and in no meaningful sense would have possessed if you hadn't measured it, okay?
Yeah.
So you're forcing it to assume that.
Yeah.
Instantaneously, the other photon, assumes the same value or the complementary value. In any event, its value is determined at that moment by the fact that you force this one to assume a definite state. Now, the way I read that is instantaneous influence across a distance. In other words,
that's
faster than the speed of light.
That's why Einstein called it spooky action across a distance. And of course, he intended that as a reductio ad absurdum and saying, well, this obviously shows there's something wrong with quantum mechanics because you can't have instantaneous action at a distance.
Right. Einstein is the one who suggested this crazy entanglement experiment.
Yeah.
And as you say, he said, look, if these interpretations of quantum physics were right, you would do this experiment, and when you measured this, it would force this one to assume the same state. And he said that couldn't be the case because influence can't travel faster than the speed of light.
Right. So it's some kind of influence then that doesn't involve causality, and it doesn't actually involve information traveling from one of the particles to its entangled particles. So they're connected in a way that just doesn't compute in our poor little hominid brain.
Well, exactly. Yeah. That's really weird.
Yeah, it is. I mean, then again, though, why should... this is a theme I probably harp on too much in the stuff that I write, but, why should the human brain, which basically, evolved to find prey and avoid becoming prey, be so fine-tuned and honed by evolution that it would be able to understand the subatomic realm?
Right. No, it's totally the macroscopic level we're designed to deal with. Yeah. But, I mean, the reason this matters is because at a kind of the level of philosophical and theological argumentation and so on, people act as if their logical intuitions developed in the realm of that apply validly to the macroscopic world would still apply when you're talking about ultimate matters, the ultimate nature of the universe and stuff.
Yeah, I mean, naturally we think that, and of course we can't, it's really impossible to imagine anything otherwise. All you can really do is kind of conjure with numbers and do these computations and show that they work. And of course all the real controversy comes in over how you interpret all of that. The interpretations are, that's where you start. Yeah.
And some quantum physicists just refuse to get into that business.
They just don't interpret. Yeah, they just
in fact, a surprising number of physicists, for my money, are really not very interested in the mind-boggling, seeming philosophical implications of their work.
Yeah, I find that a fair amount, especially with quantum mechanics. And another thing I find, like if I write something like a piece for the Week in Review or something talking about the latest amazing, weird quantum experiment. Like, let's see, there was one where they had, I guess it must have been, I can't remember if it was a particle or an atom or what, that was spinning around, literally rotating one way and the other way, both at the same time in superposition. And you write about these things and then bring out all the old spooky action at a distance and quantum weirdness, and then you always get a letter from at least one physics graduate student saying, how stupid you are, and obviously there's nothing weird about this, and it all makes perfect sense, and it's just you journalist amateurs that think it's weird, and and then you have to remind them about some of Richard Feynman's great quotes about how weird it was and how nobody understands it. And
yeah, he said, I know in his book, The Character of Physical Law, he said, people used to say that nobody understood relativity theory, but that was never true. Mm-hmm. There was always at least one person who understood that. He said, but no one understands quantum physics.
So the people that have been doing it for a long time are just as spooked by it as people like you and I who are kind of, watching it as a spectator sport. And in between, you have people who don't find it mysterious either because they choose not to think about it or because they're, kind of these rather arrogant graduate students that haven't really been steeped in the philosophical implications.
Yeah, the last thing I'll say about quantum weirdness is just, well, maybe the last thing, depending on what you see in response. But it gets back to this idea that these in the quantum world, these like electrons, for example, subatomic particles of various kinds, do not have definite form until they are measured. There are various ways of interpreting that. Yeah. Some people think that just means, well, they don't have definite form until they interact with the macroscopic measuring device, the mechanical device. Yeah. Some people think, no, it means they don't have definite forms until the measurement is really observed or registers on a human consciousness. Yeah. And there you get into these kind of ideas, some of which I guess are associated with maybe Indian philosophy. I mean, India in the sense of the country that...
Well, I think even John von Neumann was kind of toyed with that idea that consciousness is required to collapse the wave function, and
And that's freaky.
Yeah.
It's
yeah.
like the
That's
idea...
a pretty minority view, but...
It is, but I think the technical philosophical term is the ontological primacy of consciousness. In other words, consciousness is more fundamental than the material world.
Right.
And the material world's existence depends on the prior existence of consciousness. I don't know. Go try to imagine that. But anyway...
what a mess. But I mean, a lot of that... there was John Wheeler. He's at Princeton, right? Princeton physicist.
He was at Princeton for a while, then he went down to the University of Texas.
Oh, that's right. Yeah.
He had this "it from bit" idea, which John Horgan wrote about in which book?
Yeah. Maybe Rational Mysticism.
Could be.
Oh no, I bet it was End of Science actually.
Could be.
Yeah, because science is careening toward the end when you say consciousness is required to summon up the universe by collapsing the quantum wave function and creating a bit of information, 1 or 0.
No, Wheeler was open to some pretty far out.
Oh, yeah.
Very much that kind of interpretation, the dependence of, And then Schrodinger, who did the Schrodinger equation, was a mystic of some kind, right?
Schrodinger or Heisenberg?
Schrodinger, well, listen,
Schrodinger. Yeah, Heisenberg, I just remember reading... something where Fritjof Capra, the guy that wrote The Tao of Physics, which is a much maligned book by physicists that I actually thought was pretty interesting and good. But he interviewed Heisenberg once. But I guess not because Heisenberg was necessarily a mystic.
Well, I think if I've got this right, didn't Schrodinger write the little book What is Life?
Yeah, right.
And that is generally paired. It's almost a longish essay. It's generally paired with a little bookish essay he wrote called Mind and Matter, I think. And that's a very kind of mystical view of what consciousness is. And as I recall, there's this idea that consciousness is a unified thing, and each of us is just one window onto it, and so on.
Yeah, I don't know about that. With Schrodinger.
Of course, it's also true, apparently, that Schrodinger thought up all of his still remembered ideas, like the Schrodinger equation and everything, while off in a cabin having an intense extramarital affair.
Oh, that's Then there was something too about a couple of young
lovers.
Yeah, young nieces or cousins or something that he was supposedly chasing.
I don't know about that. I remember
there's some interesting stuff, and there's a good biography of Schrodinger that has a lot of this stuff.
Yeah, that paints him in some ways in unflattering terms.
Yeah,
but I remember there's this thing in his book about some comparison of two lovers to making some point about consciousness. He's depicting as a kind of actual metaphysical merger of consciousness, I think, true love or something.
Yeah.
Who knows? Well, we straightened all that out.
Yeah, and I may be misstating what the scandal was with Schrodinger. I recently read about it. A friend of mine's writing a book called The Age of Entanglement that's going to be coming out in a year or so, and she has some really interesting stuff about Schrodinger, and she kind of takes all of the stories about a lot of the old quantum people and puts them into this narrative that kind of gives sort of a really neat scenic tour of the history of quantum mechanics and entanglement.
Wow.
Yeah.
I'm all for that.
Yeah, it'll be a good book, I think.
So a double entendre on entanglement there, I guess.
Exactly right. Certainly with Schrodinger. Yeah, we'll have to. Maybe we can get her on Science Saturday when the book's nearer to completion.
I'm for that.
But there's another, and of course the other weird interpretation of quantum mechanics, or one of them, is the idea that it actually is all completely deterministic. It's just that when you measure the particle and its 1 or 0, up or down, left or right, that the universe at this point actually divides into two parallel universes, and one is true in one universe and the other in the other universe, and then you just have these universes just constantly, splitting off as you talk. I guess Hugh Everett was the person originally behind that, and a surprising number of physicists actually really prefer that interpretation to the idea that it just sort of arbitrarily, randomly collapses one way or the other.
That's where I draw the line, George.
Yeah,
I just can't buy many worlds, man.
Well, I just can't buy anything where you have entities that are in principle sealed off from ever having any causal interaction with our own little neck of the woods.
Yeah,
that to me seems like cheating.
Because according to this theory, there would by now be like how many Bobs in how many different universes?
Oh God! I mean, just every second. You know, I mean, every time you blink one eye and not the other.
Too many, too many Bobs.
Yeah, this is
But you're right, Michio Kaku. I did an interview with him that hasn't been posted yet on Meaning of Life, and he was telling me, like he was saying right here in this room, there are dinosaurs.
Yeah.
Yeah. In some other or something. No, wait, maybe we were talking, I don't know what we were talking. Anyway, he takes many worlds seriously, as I recall.
Yeah, and then there's different versions, like Murray Gell-Mann subscribes to something he calls many histories, which is supposed to be subtly different, where you don't actually believe in the ontological reality of these other worlds. And I don't know, it just...
That's...
Yeah.
No, I'm only willing to go so far. I could buy the ontological primacy of consciousness, but that's about it.
Yeah, sometimes that appeals to me. The idea that consciousness comes first and everything else is built on top of that. Since it's really, I mean, that's certainly our experience of it, of the universe.
In a certain sense, although most people find it deeply counterintuitive, I find it counterintuitive.
Yeah.
I mean, consciousness makes you view the world in a way that actually doesn't make consciousness seem... Anyway, I don't know.
Right.
At this point, maybe we should... you want to talk a little about that New York Times piece?
Yeah, that was kind of the big science story this week, was Nicholas Wade's piece on... it was called Do Unto Others... Oh, no, is Do Unto Others written into our genes?
In our genes. I've got it here somewhere.
Soared to the top of the most emailed list and... Yeah,
skyrocketed.
Yeah, skyrocketed would be the word. Yeah, why do you suppose that was? I mean, the idea that morality, that scientists are seriously considering the degree to which morality is written into our genetic code isn't new, but the stuff in the story, I think, was...
Yeah, well, it's largely about the work of John Haidt, whom I know slightly, who's done very good work in this realm, in terms of looking at the, how evolution has given us certain tendencies in the realm of moral intuition.
Oh, yeah.
You're right. I mean, broadly speaking, evolutionary scientists have been talking, for a long time, but I would say for a few decades they've been talking with some degree of confidence about certain of our aspects of our moral logic and intuition being in our genes. Notably, the idea that the intuition that that good deeds should be rewarded, bad deeds should be punished.
Yeah, right.
That seems to follow from the theory of reciprocal altruism developed by Robert Trivers, drawing on the work of George Williams.
Yeah. Kind of the tit for tat game theory stuff.
Yeah. The idea that it isn't so much that we're designed to consciously go around doing favors just so they'll be reciprocated, but that rather the emotions that lead us to do favors for people, and particularly for people who prove themselves as friends, that the whole emotional infrastructure of that kind of behavior is a product of evolution that exists by virtue of the logic of reciprocation.
Yeah. I mean, I certainly would buy that. And in Haidt was talking about some of the real deeply rooted kind of, I guess you almost like engines of morality. And he talks about something as basic as the disgust reflex, where he gives some really disgusting example, like why is it that you would you really recoil at the idea of eating your family dog, even if it had died of natural causes. But the idea that you would then, cook it and eat it is just something that most people find totally disgusting, without even really having to think why.
Right. I mean, he's saying that this. For one thing, he's saying, bear in mind, this system, the moral intuitions based on reciprocal altruism are probably just one it's probably just one realm where the moral intuitions are shaped by evolution.
Yeah.
And the other ones include this area where he has done a lot of empirical work on places where very visceral feelings of revulsion shape our moral intuitions. He's done this interesting work where he asks people about incest. And, of course, incest has long been a case where we have pretty good theoretical reason to believe that humankind has a built-in aversion to incest because of the deleterious genetic effects that something like brother-sister incest would often have.
Including the gene pool. But it's not like people are thinking, oh, well, this is really bad because...
Right, they don't consciously think that out necessarily.
Right.
So he did these experiments where he videotapes people, and you ask them, okay, Sally and Billy are brother and sister.
Yeah.
They want to, and you sketch this scenario where they want to have sex. It won't hurt anybody else. Nobody else will know. They both enjoy it. And what's wrong with that?
Yeah.
And people will have these objections. Well, what would what would the child think when growing up with two parents who are brother and sister? The child would be ostracized. And they say, well, no, we can set it up. Say, definitely won't have a child.
Yeah, right. So the brother could get a vasectomy. And,
right.
Yeah, and so then you also wouldn't have to worry about creating a child that was more highly prone to genetic effects because of the inbreeding.
Right, and so they counter every rational reason given for the negative judgment of incest, and people are ultimately, even when they give up on having any articulable reason, they still insist it's bad.
Well, still.
What's that?
They'll say, still. It's just disgusting.
It finally boils down to yuck. It's gross.
Right.
Sorry.
I just there's a test that Haidt has that you can link to from Wade's story on his on a website he set up to do this kind of research, and one of the questions he asked was, it's what would you do for $1 million? And he has all these questions like, and I think one of them is that your family pet has died of natural causes, and how much would I have to pay you for you to cook it and eat it? And it goes from $1 million, $100,000, $10,000, $1,000, and then down to I'd do it for nothing. And he asks some other questions.
Do you know what the percentages are on that? Like, what's the average payment somebody demands?
Yeah, actually, let me find it. I was taking the test. It's called yourmorals.org. Let's see.
I'd totally do it for $1 million.
Well, yeah, that's kind of what I thought.
That would be the salvation of Blogging Heads TV,
Yeah, I think I said, I'm sure I picked $1 million, and I don't know, maybe 100,000. I think I held out for $1 million. But, the way, I guess, the only statistics I have here are for myself. And it concluded that it would take an average of $667,000 to get me to violate what Haidt calls the harm foundation. In other words, doing something that would cause harm to another person.
Do you remember what it is exactly that you were willing to do for money in that realm?
No, I don't. I mean, some of the questions were things like taking a child that you don't know and sticking a pin into its hand really hard. And for that one I picked, I would do it for no amount of money. But there were other ones that were a little lesser, that didn't involve physical harm necessarily. I can't remember what they were, but I'm a little alarmed that I came in at $667,000 because obviously I wasn't holding out for $1 million or saying that I wouldn't ever do it. And
so wait a second. Even for $100 million, you wouldn't do that to a child?
Well, I don't know. They didn't ask $100 million, but
well, I'm asking, George.
Yeah, I'll say no.
Well, look, you could take $50 million and save God knows how many lives in Africa.
Yeah.
And then retire on the rest. Would you do it then?
Well, I get maybe if it didn't really hurt that much, but certainly not if it caused any lasting damage. It's really hard to think about these things.
I've concluded that you are not a utilitarian, George.
Well, let's see. My cheapest one was it would take me an average of $30,250 to get me to violate the in-group foundation, and I forget what that is, but But, the interesting thing about this was when you first sign onto the site, you say whether you're a liberal or a conservative and to what degree you're one of those two. And then the first part of the test that I had taken earlier ask different kinds of questions. That again, it involved this idea of how important is it? I mean, how much do you judge an action as being immoral if it results in personal harm to another person, or how important is it to you that things be fair, or that things respect authority, or that things respect your loyalty to your in-group? I know one of the questions was, would you take $1 million? How much would we have to pay you to call into a talk show in a foreign country anonymously and make disparaging remarks about the United States? Or how much money would it take you to go out to the town square with a megaphone or something? I mean, I'm not remembering this exactly right. And say really disrespectful things about George Washington and Thomas Jefferson and stuff like that. I mean, 100,000 maybe 10.
And George Bush, what, $1.50?
Oh well, yeah.
You pay them.
For that, the choice is I do it for nothing. But
yeah.
Okay, so that's where on my in-group ratings. That's what violating the in-group foundation means, would be doing something like that, dissing George Washington. And I'd be willing to do that. The test tells me for an average of $30,250 a shot.
Yeah.
Yeah.
That's
How about you?
To diss George Washington?
Yeah, in public.
Well, in public, I'm just kind of shy about stuff like that.
Well, that's true.
I mean, I also, you'd have to pay me that much to get me to go around with a megaphone yelling George Washington was a great guy.
Well,
I don't like the megaphone thing.
Yeah, that's kind of a flaw. I don't think he actually used a megaphone. But yeah, when I was taking the test, I'd think, well, this would be something I would just really find difficult, being a fairly introverted person. But,
right.
And that's why I might hold out for $1 million.
But, I mean, if I already had their attention, and in some legitimate forum, say you're talking in front of an auditorium full of people.
Yeah.
George Washington?
Yeah.
Well, first of all, he was not a paragon of virtue,
Well, yeah, that's true. So there's a lot of complications.
Yeah.
But I guess the interesting idea is that, where morality comes from and the idea that there's certain basic things, like based on the revulsion kind of reactions that are probably wired in at a really deep chemical level that causes societies to develop this moral superstructure that sits on top of this kind of foundation of, this real basic unconscious stuff gives rise to these more well-defined kind of algorithmic rules where you say, do unto others and all that.
And here, people react in one of two ways. Some people find it reassuring to think that the infrastructure for our moral decision-making may be in our genes.
Yeah.
They think that's like an affirmation of absolute moral values or something. Some people think the exact opposite, which is, this is a mere byproduct of natural selection.
Yeah.
This calls into question my moral intuitions.
Yeah, and like people like Francis Collins, the evangelical Christian, really great scientist, is the head of the Human Genome Project, and he'll argue that the reason that we have morals and moral behavior and altruism shows that we must be there must be a God.
Yeah, he.
So he doesn't.
I actually talked to him about this too, and he is very big on the idea that evolutionary psychology cannot explain the full array of moral responses. He wants there to be forms of altruism that are inexplicable in scientific terms, and that to him is evidence of the existence of God. He was, I think, he's a converted. He had kind of a conversion experience, and one big thing leading up to that, I think, was reading C.S. Lewis's book Mere Christianity, and Lewis makes the same, very much that argument. Of course, Lewis was making it back before Darwinism had undergone these theoretical refinements that make altruism certain kinds easier to explain.
Yeah, and it's really not nearly the mystery that it used to be. So that I found Collins' book pretty unpersuasive at that point. Just, it seems to me that there's certain actions that, can be difficult to describe evolutionarily, but there's a lot of them that really seem to be falling to evolutionary explanations.
Well, as you know, I'm a little bit of a Darwinian in this regard, so you're not going to have an argument.
I was too. Yeah, I mean, the idea, of course, sacrificing yourself for someone you're related to is explained by, it's some of the same genes that were, then would be more likely to spread through the gene pool. So, it's kind of justified by Dawkins' view of the selfish gene perspective on evolution. And
yeah, the selfish, that's often misinterpreted. I mean, that's a reference really to the work of mainly William Hamilton and his theory of kin selection. The idea there is that, first of all, it isn't that the gene thinks anything through or is conscious, and it isn't that we are selfish, although in many ways we are, but anyway, in the case of kin-selected altruism, the gene is being selfish from its own point of view when it motivates you to sacrifice yourself for the sake of a close relative.
Yeah, so that's easily explained. And
it is,
gets
although
a little
it was
harder when it's not a close relative, but there's good reasons there too, right?
Well, there's a whole second body of theory called the theory of reciprocal altruism, developed by Robert Trivers, George Williams, which I alluded to, and to my mind, that pretty successfully explains. It explains a lot of forms of altruism. People pose puzzles like, why is it that we sometimes give money to homeless people who will never help us? And I think part of the explanation may be you have to remember that in the environment we evolved in, a hunter-gatherer environment. Mm-hmm. There was just about no such thing as somebody you would never come across again. And if you neglected someone who was in need, if there was an easy way to help some really needy person out that would mean a lot to them and come at little cost to you, that would probably be a good investment in a hunter-gatherer village.
Yeah, you might run into them the next day and they might have a big stick.
Right. Yeah. Or they might be able to help you out down the road. And one thing you'll notice when you, at least in my experience, is that we've all had the experience probably of not giving money to a homeless person. Yeah. I mean, sometimes you're in a hurry. Even if you try to do it, sometimes you're in a hurry.
Or if they're really, really aggressive.
Yeah, but suppose they're not. Yeah. In my experience, it's a lot harder on you psychologically to not give them money if they make eye contact with you and see that you didn't give them money.
Yeah, when you do, you feel good, and you get a little, release of, dopamine or something that...
one of these rewards, but if you...
and then you feel, wow, you feel good about yourself, and this, and it makes sense that would be wired in because of this hunter-gatherer's environment in which we evolved, and then it would result in these things we do without thinking about it. It's like... Or if you're doing a favor for a colleague, I mean, on one level, maybe if it's a colleague, you're thinking that this will help me, further down the line. But if it's not that kind of favor, still, it's to your advantage to be known within your peer group as somebody who helps other people out and is generally a good person. And this could benefit, and it could be done entirely unconsciously.
Yeah, reputational effects are another thing invoked to explain, by Darwinians, to explain why we would do things for which there's no obvious reward. Yeah. You're building up a reputation as a good person, a reliable person, and again, you got to remember we evolved in an environment where pretty much all of our behavior would become known by every relevant person in our lives. Yeah. So
it makes it seems like to me like a very, very, very persuasive argument for how morals and altruistic behavior would evolve without any need for some mystical supernatural spirit, and yet it would help explain why we might invent such a supernatural kind of spirit to really for one thing to explain where these things come from, pre-science, and also to it's kind of a cohesive factor to to instill this even more stronger in later generations. And basically, going from it being genetic to mimetic and transferring it culturally, what had been instilled in us genetically. So,
yeah, my daughter's starting to fool around on the piano, so we may have musical accompaniment for the remainder.
Oh, that'd be nice. Yeah.
So I was a little distracted, wondering if I closed the air conditioning vent, if it would have any effect. But there's also this. Of course, there is a group of Darwinians who think that the kinds of explanations we've been talking about aren't adequate, and they want to invoke something called group selection, which, when it's meaningful theories of group selection, and I actually think some of the things being trotted out as group selection are actually not meaningfully different from the old individual selectionist theories.
Group selection, maybe we should back up and talk about what that is.
Well,
it used to be very, very frowned upon, and then I get the feeling that more recently there's less pernicious versions of group theory that are considered more acceptable, because they're not so radical.
Well, there used to be, there was a wave of particularly simplistic versions of it, and, they would say, well, notice that when there's a drought and there's not much food to eat, some kind of deer or even human beings tend to refrain from reproduction, and then they would say, the group selectionists would say, that's for the good of the species.
Yeah,
okay, they're
right.
doing it so that there won't be any, overgrazing that would wipe out the whole species. And then people looked at it more closely and said, well, no, actually, if you look at the kind of nutritional economics of it and their survival prospects, you can actually explain this as just being the smart thing to do from the gene's point of, individual selectionist point of view, because your own child's Your own reproductive prospects are better served if you refrain from reproducing for a few months or a year until things are more auspicious.
So it's still individual competition that's driving the evolution. It just manifests itself as something that kind of looks like the group being the vehicle.
Yeah. So this kind of facile resort to the good of the species, good of the herd type logic fell out of favor. And these individual selectionist theories had success doing what the group selectionist theories used to do, like explain altruism in humans. Then there's been a little bit of a counter-reaction of so-called group selectionists, not so much talking about good of the species behavior, but saying, well, if you got two groups of humans competing, you can imagine things evolving in some sense for the good of the group if you think of it carefully. And basically,
so the individual could be thought of as an organism, as an organ or a cell within this superorganism group, and then if certain genetic behaviors that the group did as a whole would then help would increase the survival rate of the individual members, but it's still really the individuals again who are.
Well, it certainly all ultimately has to come back to the proliferation of genes.
Because the group doesn't have its own genome.
No,
and the group itself doesn't replicate and is not subject to the evolutionary pressure. So it's more like a second level manifestation of the individual.
Whether you're a group selectionist or an individual selectionist, you believe that those genes flourish which are conducive to their own replication. And the question is, what is in a sense, the vehicle that is being used at any given point for the genes? Can you think of the group as being the vehicle? Or the individual or the family? And if it's the family, do we call that a group or what? And this is a useful clarification that's, I think, come up that is due to the group selectionist kind of backlash that it's not this distinction between what is the unit of selection and what is the vehicle of selection. But at the same time, I think to some extent the progress of or the resurgence of group selection is kind of overstated in the popular media. I think
this came up. When I was talking to John, I guess last week, there was this this kind of fray between Richard Dawkins and Freeman Dyson on Edge.org.
Right.
Yeah, and then Dyson was, Dawkins was accusing Dyson of making a schoolboy howler, quote unquote, by talking about selection happening at the level of the species instead of at the level of the individual. And then Dyson shot back at him, and it was interesting. And when I talked about it with John, I hadn't actually read Dyson's article where he originally did this, which was this piece that appeared in the New York Review of Books this summer, which was actually really good and a lot more interesting than the flap with Dawkins.
Yeah, I heard that. I often listen to these things of yours and John's, like while taking a bike ride on Saturday or something.
I like that image.
Yeah, I do. And I remember wanting to dive in at that point.
Yeah.
Because it sounds to me, the quote from Dyson was something to the effect of natural selection rarely happens, or evolution rarely happens without one species going extinct, or something to that effect.
Yeah,
and that is indeed something that that few, if any, evolutionary biologists would sign on to.
Yeah, Dyson said, here it is, with rare exceptions, Darwinian evolution requires established species to become extinct so that new species can replace them.
No, I think pretty much nobody would say that. I mean, a lot of evolution, and most evolutionary biologists would say, well, I should be careful, but a whole lot of evolution just goes on through competition within a species, and and some version of that competition is going to go on regardless of whether any surrounding species go extinct, okay?
Yeah.
Individuals are competing for reproductive success within a species, and that's going to lead to meaningful evolution, and you could have a world in which no species ever goes extinct, and you would still have massive quantities of evolution.
Yeah, and you're going to have these arms races between individuals and different species too. Where the prey learns to run faster or camouflage itself because its predator has developed sharper teeth or new wings and things, and then one of these species can eventually disappeared from the fate of the earth, yet while it was here, this individual competition was driving change, throughout the biosphere.
Or it cannot disappear, and yet still you're seeing interspecies competition drive evolution in that case.
Yeah.
That's a good point. I mean, the arms race could go on forever. It's not the case that one of the species has to disappear for the evolution. Now, when species disappear, it affects the course of evolution.
Yeah.
But I think the way this is put is, how often does selection happen among? Well, I won't get into it because I'd probably screw it up. But one important point is that this question, species selection, if it happens, when it happens, is a relatively small subset of the landscape of possible group selection that biologists talk about. A lot of group selection, if it happened or when it happens, would itself be within species, not between species. So, in that case, it sounded like Dyson had said something that very few evolutionary biologists would buy.
Yeah, and then when I went back and read his article, it was kind of a shame that that's really what the dialogue. I guess it wasn't really a dialogue between Dawkins and Dyson concentrated on. Dawkins basically wrote this letter that was read aloud at a gathering where Dyson was there, and then he issued a rejoinder. But when you go back and read this article that was in the New York Review of Books, it's really rather wonderful. Dyson starts out talking about going recently to flower shows and tropical fish shows where people, amateur breeders, and have been doing their own genetic engineering the way farmers have done genetic engineering for centuries, just by picking traits they want to emphasize and interbreeding, causing the interbreeding of their subjects. And he was just talking about how wonderful all these variations are that are kind of semi-artificial since they were human breeders, and then talks about how the next big thing will be genetic experimentation kits that everyone can have, so you can have fun making your own pets and things. So it's definitely draws you into the essay. But then what really struck me, he was talking about this idea that I guess came from a biologist named Carl Woese, Woese, who was talking about a pre-Darwinian era that was back when all you had was single cellular organisms, and there was supposedly not anything like Darwinian evolution, but just all these unicellular organisms that were kind of sharing their DNA and their little genetic tricks and swapping DNA horizontally is how Dyson describes it, and which I guess bacteria still do. And then out of this, at some point, one of these cells just happened to get the right combination that gave it a little edge, and it founded the line of eukaryotes, which are the single cells that have nuclei which combine to make us, and the other would be the prokaryotes without a nucleus, and then something called the archaeobacteria. And so he was arguing that evolution didn't actually begin until that first little cell got a leg up on the others, and that didn't strike me as how I understand evolution.
No, I think as soon as you've got genes proliferating and varying at all, it has to be the case, right, that some have properties more conducive to their own replication than others, and as soon as that's happening, then natural selection is by definition happening. They may be slopping around, and kind of horizontally in a sense, and jumping from one organism to another, which is fine, but there's still natural selection is happening because some genetically based traits are being favored at the expense of others.
Yeah, as soon as you have replicators, even if it's just purely molecular, and selection pressures are going to be there, and you're going to have evolution.
I would think.
Yeah, and that's basically was Dawkins made that point a little more nicely than he did the other. And then in Dyson's essay, he goes on to describe after the Darwinian era, which is most of life on Earth, that now we're in the post-Darwinian era, where it'll be just like with the bacteria and single cells swapping genes horizontally, except now it'll be done through genetic engineering, and with these little genetic engineering kits you can buy at Kmart someday soon.
Yeah, I've been looking for those at Kmart. Well, it's certainly true that I think from here on in the bulk of change. I mean, over the next century or two, the great bulk of changes in the human genome will probably be consciously engineered by humans.
Yeah,
that's a very different kettle of fish.
Yeah. It's a neat essay. Dyson's
Dyson's a great thinker, and one thing I like about him is he is very aware. This gets back to the quantum physics discussion. He is very aware of the limitations of our understanding of the universe and perhaps of our ability to understand it.
Something that really struck me about Dyson that I really liked was something he wrote. Just basically saying, why do we need a theory of everything in physics? It's really great that we have, quantum theory, as we started talking about today, and that we have the big theory of general relativity that maybe we can talk about another time. And instead of really being obsessed with coming down with the one theory of everything, just let diversity reign.
Well, if we had more time, this could be a segue into my harangue against superstring theory.
Oh, let's do that another time.
I think we may have to. What's the record for you and John in terms of longest Science Saturday?
1 hour and maybe, I don't think we ever got to 1 hour 10. And I according to my clock, we're at 1:08, 32, 33, 34.
So this could be the record?
It might. I think it might.
Wow. This is a very special moment.
Yes, well, let's go for 10.
Yeah, and so maybe I will have to tell a story.
Yeah, tell a story.
In Horgan-esque fashion. Gosh, I wish I could think of a story about him.
Yeah.
But no, that wouldn't be fair.
I can tell one about you.
I'm not sure we want that, George.
It's a good story.
Okay, go ahead.
Actually, I told it to John, but you may have missed this one. But
No, listen, I doubt I've missed anything that's been said on science.
okay.
Is this the one where it was? Gets back to reciprocal altruism,
exactly. That's
doesn't it?
why I was going to bring it up. It was when
I maintain that there's an error in this story.
Okay,
George.
this is the story. Very quickly, my version of the story, in my memory, is that it was when I was working at the Week in Review at the New York Times, and across the hall was the book review.
This is kind of embarrassing for me, but go ahead. Go ahead.
And then I picked up the paper book review. That was like pre-web.
Yeah, there was. I remember when there was paper. Yeah,
isn't that cool?
Yeah.
No web. And and it had this prominent review of The Moral Animal, and the review was by Steven Pinker. And I just sent you a quick email congratulating you on the review, assuming that you'd seen it. And then I got back to my apartment, and the phone rang, and it was Robert Wright. And what I remember is you were just asking me to, read you parts of the review, which I was happy to do because you actually hadn't seen it. And then at some point you said, "Well, you know why you're doing this, right?" And then you explained in very moral animal fashion.
In other words, I know why I'm doing it.
No, why I'm doing it. Why I'm taking the time, standing here on the phone, reading you your review while you write it down very quickly, so you'll have a record before it comes out. And it was why I'm engaged in this altruism, and I'm expending energy and time to help you out for free. And then, of course, it gets back into this whole question of altruism outside of the kinship groups and things. And I just thought it was a rather great story that you would have this evolutionary psychological evo-psych explanation for it all. So it's kind of my favorite story I tell about Robert Wright.
I may suggest some other ones. I find that mildly embarrassing just because I sound so kind of desperate. I would say in my defense that back in those days, I mean, the New York Times Book Review is still very, very influential. But there now are these kind of there are blogs, and the web has generally decentralized the concentration of power in the media generally, I would say.
Yeah.
And in those days, something like getting the fate of your book was really, it was not wholly dependent, but it was heavily dependent on the way it was treated in the New York Times Book Review, and that still matters tremendously.
Yeah.
But it was a big moment when if your book was reviewed in the New York Times.
And then getting a full page review by Pinker on page 2 or 3 is pretty good. Yeah.
No, I was happy.
Yeah.
And the other, but I kind of think I was probably kidding. I mean,
of course you were.
Yeah. Okay.
Yeah, I meant it to. It was done with great Bob irony.
Yeah. Okay.
Yeah, it may not have come across when I was talking to John.
Yeah, actually, no, I think I understand the story better. I think previously I thought you were talking about my motivation in...
no. It was my motivation in doing it, and then the tit for tat was... I get to be on Blogging Heads TV.
Lucky you.
And work for free.
Your reward is you get to work for free. Don't thank me, George. It's just the kind of guy I am.
Yeah, we appreciate that, Bob. Okay, next time, superstring theory, okay? We broke the record, by the way.
What's that?
We've broken the record.
We have broken the record, and John is now a mere asterisk, I would say, now that we own the record.
Yeah, maybe this will encourage him to come back next week.
Get his competitive juices flowing again.
Yeah, we could get this up to, God forbid, an hour and a half. Yeah, I don't know.
I think viewers would thank us if we brought it to
let's try to go back down toward an hour.
Okay.
Okay, Bob.
All right, well, this was great, George. Thanks
really
a lot.